you guys to do today. You've got the post-assessment you got to do, the true-false, the pre-assessment on rocks and minerals, true-false. You've got your vocab Kahoot. You're going to have these, the notes, and then you're going to have a flowchart activity. So 5 things to do today. So we're going to do rocks and minerals now. So first thing we're going to look at in rocks and minerals is minerals. We're going to start at the basics, start at the beginning. So minerals are naturally occurring, which means they're not man-made. They are inorganic, which means they're not made by living things or things that were living at one point in time. They're not made up that way. They are solid. They're not liquid. They're not gas. They have solid. They're definite size, volume, and shape. And they have a definite chemical composition, which means they are made up of the same chemicals. In halite, it is made up of sodium and chloride. Quartz is made up of silicon and oxygen. They are made up of those 2 things, and they have a specific amount of those 2 things in them to make up that type of mineral. They also have, minerals have a crystal structure, so they tend to look crystal-y type looking, which means they have, their atoms are arranged in repeating patterns. Okay, well, there's 2 ways they can form. You've got as lava, as it crystallizes, as it cools and crystallizes, and then magma as it cools and crystallizes. We will get to that when we get to igneous rocks, which is going to be on Tuesday. And then you have crystallization of minerals dissolved in water. There are 2 types. First you have is the evaporates over here. This is a picture of the Dead Sea. This is the sea that is totally saturated by salt. And you can see once that salty water washes up on shore, all the liquid water, the liquid H2O, evaporates off, leaving the salt particles. So it looks like a beach full of salt. And then you have this right here. Now, what the heck is that? That's a cave. This is a form of precipitate, which means that all these minerals and stuff that are in the water, you've heard of like hard water and stuff like that. That means they have minerals in them. And as they seep down into the earth, they can collect even more. And as they seep down and they find these caves, either they're eaten away, but the caves are limestone that has been dissolved away, and as it's dissolving, this water comes in and it starts dripping and dripping and dripping, and it leaves all these minerals right there on them, on like stalactites or stalagmites. That's how caves are formed and why they look kind of cool. Okay, so there's some uses. Why are minerals important? Well, some of these minerals make metals, or are metals. They're elements that have a shiny surface and are able to conduct heat and electricity. And here's some minerals right here and their uses. Now, what mineral would this be? If you look at the back of your reference table, which you definitely need today, Fe is on the bottom, and that stands for iron. If you have a cast iron pan, you should have known this is iron. Then you have this thing called bauxite. It is made of AlOH. Al is aluminum. And look at this. Bauxite is also aluminum cans. Now you have chalcopyrite. Oh, I can't say that one. And if you look at this looks, that's Cu, that's copper. Gold. What is gold made of? Gold is made of gold mineral. It is an actual mineral. Pretty cool, huh? And then you've got aragonite, Ags2. And that would be some of your jewelry. That's silver. Okay, so it can also be made, those metals can be made to form an alloy. So here you've got tin and copper added to make bronze, copper and zinc to make brass, like trumpets, iron, chromium, and limestone all put together to make pewter. And then you've got a mixture of lead and tin to make steel. So some uses of minerals continued. They've got non-metals, elements that have dull surfaces and are poor conductors of heat and electricity. So here's some examples. You've got this yellowy looking one, and it's on the end of matchsticks. That's sulfur. Then you've got like these crystally like ones that form table salt. Well, that's halite. Then you have this really powdery, soft stuff right here that makes up drywall. That's gypsum. Then you have this rock right here. I know it doesn't look like much, but it makes baby powder. That's talc or soapstone. And then this last but not least is this, that right there, what's on that tip? That is graphite. And it's used in pencils. Some other ways to identify, okay, so there's ways to identify minerals. There's specific ways. And they can be identified by their physical and chemical properties. Now, if we look at physical properties, you must use your reference table on page 16. It's on the back. This shows you all of the ways to identify physically a mineral. So get out your reference table and look at page 16. One of the things you will notice that is not on there is color. Color is not really a good, reliable method. Well, why? Because some minerals, yeah, they have one color, like this really pretty malachite or this, in a way, pretty sulfur. But others have many colors. Like, look at this. These are a whole bunch of different types of quartz. You got rose quartz, amethyst quartz, smoky, can't read that one, emerald, turquoise, opal, white. And then you have this right here. This is like so my favorite. This is hematite. It is gorgeous. I love hematite stuff. Then you have streak. This is when you take the minerals and you streak it across a porcelain plate. It is the powder, the color of the powder that is left behind. So one example is hematite. You can't go by the color of the actual stone, the actual mineral, because you can look on the left, you have this darker, almost black, shiny looking hematite, where on the other side you have this earthy looking red hematite. But when you scratch, they both have a red scratch, albeit the one on the left is more of a darker, blackish, almost black color with red hues, but they're both red. Okay, another way to measure is hardness. It can easily measure a measure of how easily a mineral can be scratched, how easily it can be. So the softest mineral we have is talc. The hardest mineral is right here. It's called a diamond. And you have this thing called Mohs hard scale. That's how they figure out how hard things are. So there are a couple links, and if you look at your reference table, you can easily fill these in. At number 1, you have talc. At number 2, you have gypsum. At number 3, you have calcite. And at number 7, you have quartz. I know olivine is pretty close, but quartz, we're going with quartz for this one. So we're talking about how to figure out how hard something is. You can just scratch whatever, right? No. You need to have known hardnesses, like your fingernails. Not the fake ones, your actual real fingernails have a hardness of 2.5. A penny has a hardness of 3.5. And nails, the ones that you hammer in, have a 4.5. And then these glass scratch plates have a 5.5. So will these minerals be scratched by these common objects? So if calcite's a 3, will it be scratched by a penny? You bet your butt it will. How about gypsum? Gypsum is in a 2. What about our nail? Our nail is a 2.5. And I can tell you for a fact, yes, gypsum absolutely does, because I can go like this and it looks like dandruff is dripping down. It looks actually kind of cool. Olivine is a 6.5 to a 7. Will it be scratched by that glass plate? Nope. Will olivine scratch the plate? Absolutely. How about quartz? It already says no. Quartz is a 7. The nail is a, sorry, I'm going back, a 4.5. So yeah, it'll most definitely. So mineral hardness is a result of the mineral's internal structure. It's how it's made on the inside, how the atoms are bonded together. Another property we're going to look at is cleavage and fracture. These describe the way the mineral breaks. So if I was to take a hammer to it, what would it do? And so cleavage is when it would split along a flat, smooth surface. So if I was to slam that hammer down right on this mica, it's only going to break in one direction. It's actually going to more like peel. Well, if I hammer it down on this nice little boxy looking thing called galena, it's going to break in 3 different directions. Along that plane, and along that plane. Well, what about this one? This has got 3 directions, but it's rhombohedral. This calcite will also break in 3 directions if you smack it with a hammer. All right, so look, after we got that done, that's cleavage. Now we're looking at fracture. Now fracture is when a mineral breaks into a curved or irregular piece. So that curved piece we're talking about, that's that conchoidal. That's sulfur and quartz. And you can see it kind of like this. It looks almost like a shell, conchoidal. And then you've got the non-conchoidal. This pyrite looks more like a boxy looking type thing. This looks almost boxy, but it's not a definite shape. So you've got pyrite and magnetite. Okay, so the next physical attribute is luster, the way a mineral shines or reflects light. So the first type you've got is metallic. Here's 3 different metallics. This one right here is gold. This one is what galena looks like. And this last one, that is what magnetite looks like. And then the next one, you have non-metallic. It reflects light, so it looks kind of pearly in this case, glassy in this case, waxy, brilliant. That's one way to define diamonds, is its brilliance. And this last one looks really earthy or dull. All right, another way is density. We've done this before. It's a concentration of matter. Different mineral samples of the same size can have different densities. So looking at this, looks kind of familiar. We just saw it. Its mass is 99 grams with a volume of 13 milliliters. What's its density? Again, 99 divided by 3, 13 is a 7.6 grams per centimeters cubed. Now on the back of your reference table, you will find all of what I just talked about, except for color. And if you look back there, it's going to tell you the density of only one mineral, and that is galena. It is fairly dense. So some special properties. We've got magnetism, where magnetite magnetizes, attracts metals. And then you have this bubbling thing. So calcite bubbles when you put acid on it. Pretty cool. Because of the calcium. Because calcium reacts with water and acid. Okay, so an unstable mineral that emits radiation. This is radioactivity, like uranium. That is a mineral, and it is radioactive. This last one you have is double refraction. It's the splitting of a light wave into two different light waves. So finally, we have this silica and oxygen make up about 74% of the Earth's crust, which make up the huge group called the silicates. Very important, kind of remember silicates. All right, so last thing I want you to do is pause. You should pause this, try and figure out which ones these are, match them up. Calcite, magnetite, pyrite, graphite, olivine, sulfur, galena, gypsum, hyalite, and fluorite. Check it up. All right. Hope you guys have a great day.